Good morning, everyone, and welcome to IAM Roles Anywhere session. First of all, let me thank you today for coming here. It is a pleasure meeting all of you. My name is Mohammed Kashk. You can call me Kashk. I go by pronoun he, him, and I am the product manager for IAM Roles Anywhere. Today in this session, I have with me my colleague, Raj Endla, and he is a software development manager for IAM Roles Anywhere. And I have also Robert Alcorn. He goes by Bob, and he is a senior software development engineer for IAM Roles Anywhere. How many of you use IAM roles and get the benefit of getting the temporary credential for your workloads that are running on the cloud? Great. But what do you think about the other applications that do not run on the cloud? In the fullness of time, we believe that almost all the applications will be running in the cloud, but also we understand and we respect that many of those applications for our customers still at the moment are running on their data center or in other places. What if you need the same level of robustness of IAM roles that you get in the cloud for those applications that do not run in the cloud? You have heard yesterday in Kurt's keynote that this month we launched IAM Roles Anywhere that extend the availability of IAM roles to your workloads running outside of AWS. We are super excited about it, and today in our session, we'll be giving an introduction about IAM Roles Anywhere, and we will show how it works and the steps needed to configure and set up the IAM Roles Anywhere to start obtaining the temporary credential for your workloads. We'll also show how you can audit the identities that were authenticated using IAM Roles Anywhere. And at the end of the session, we'll be running a demo where we will go step by step on the different procedures needed to set up the IAM Roles Anywhere until obtaining a temporary credential for your workload. We have been building bridges between application on the cloud and those that are running outside of the cloud, maybe on your data center or elsewhere. For many years, with services like AWS Outpost or AWS Local Zone. However, we heard from our customer that one of the main challenge was the undifferentiated heavy lifting of managing access to AWS resources for workloads running outside of AWS. Today, your application running on the cloud, they use IAM roles and policies to securely and easily access data, resources, or services on AWS. But when your application are running, but for the application that are running outside of AWS, and you want to make use of AWS services, you typically use long-lived credential that you need to store, manage, and maintain. Also, customers have told us that the first step in their journey to move to the cloud was to migrate their data to the cloud by giving access to their application running on their premises to access AWS resources, such as giving access to your data lake, to access Amazon simple storage service, which is S3 bucket. And in order to do that, usually it's being done, required to be managed using the long-lived credential. Additionally, the security and the compliance team frequently require the rotation of these secrets, which in turn requires you to build those kind of systems that rotate the long-lived credential in a secure way in order to ensure the same high bar standard of those applications like the one that are running on the cloud. To make this credential safer and more secure, you might be using third-party tools or open source in order to manage, operate, upgrade, and handle those tools. And the reliance on third-party tools also requires the application developer to use different access management, different development pipeline, or maybe testing processes that you need to have it to ensure consistency between the one running on AWS and the one running outside of AWS. And when you are ready to migrate and move your data and workloads to AWS, you typically need to refactor those applications in order to remove the dependency on those third-party tools. And this is why, to make it easy, to you, um, and this is why, to make it easy to you, we launched the general availability of IAM Roles Anywhere that that is available in most of our commercial region at no additional cost. Now, with the question, what is IAM Role Anywhere? So IAM Role Anywhere, it's a new AWS identity and access management that is available in most of our commercial region that was launched this month that enables your workloads such as servers, application, or containers to access AWS resources such as Amazon S3 buckets or Amazon DynamoDB databases, regardless where those workloads are running. They can be running on premises or in hybrid scenarios. It enabled to use the same IAM roles and policies that you have configured to your native application running on AWS to access AWS resources to access AWS resources. Also, it uses the public key infrastructure mechanism with X509 certificate as the root of trust for obtaining the temporary credential. And in order to build that trust, you need either to configure your ACM PCA, which is the AWS Certificate Manager Private CA, Certificate Authority, or you can register your own PKI into IAM Roles Anywhere. You can, IAM Roles Anywhere provides a different options to monitor the service in order to ensure the reliability, availability, and performance. One of those options is that you can leverage the subject activity tab, which exists in IAM Roles Anywhere console, or you can also leverage the subject APIs in order to audit all the identities that were authenticated with IAM Roles Anywhere. You can also use Amazon CloudWatch metrics in order to know the number of successful or failed requests that were invoked and obtained a temporary credential for your workloads, and also to monitor the days, the days to expiry for your CA certificate and set an alarm that you can get a notification whenever it's nearing expiry and take whenever needed actions to renew your CA certificate. Also, you can use the Cloud3 Logs, and this is to log all the APIs that were invoked by IAM Roles Anywhere. In case you have already a trail that is configured, you can set it up to get continuously logging about all the logs related to IAM Roles Anywhere, to the APIs logs related to IAM Roles Anywhere. And in case you don't have even a trace that is configured, you can still see the recent activity that were triggered by referring to the history tab in the Amazon Trails console. Last but not least, you can also use the IAM event, the integration with Amazon Event Bridge, where you can get an event notifications whenever the CA certificate is nearing expiry, or whenever the leave certificate that were used by your workload to obtain temporary credential is also nearing expiry. And you can set a rule for these events to trigger an action, such as triggering and invoking an AWS Lambda function, or maybe an Amazon SNS topic, in order to take whenever needed action whenever this event is generated. So let me here first start by an introduction about the public key infrastructure, which is the PKI that IAM Roles Anywhere relies on to build the trust between the your AWS account and the CA certificate that is being used. In order to build the trust, as I was referring, you need either to refer an existing ACM PCA, which is the AWS Certificate Manager Private CA, or you can register your own PKI. PKI uses a pair of keys, which is the public and private, where the public is usually available in the digital certificate, while the private, you need to store it in a secure place. PKI involves the generation and distribution and verification of the digital certificate through the public key encryption. And the certificate authorities are entities that are trusted to issue a digital certificate. The CA issues signed digital certificate that affirm the identity of your of the certificate subject and bind that identity with the public key contained in the certificate. The CA signs a certificate by hashing the content of the certificate, by hashing the content, and including the public key in the certificate. And when a client application, such as a web server, would like to affirm the identity, they use the public key in order to validate the signing of this certificate. To authenticate a request for credential, IAM Roles Anywhere validate the incoming signature by using the signature validation algorithm required by the key type of your certificate. And once the signature is validated by IAM Role Anywhere will check that the certificate upcoming in the request were generated from the CA that is registered within your account. So now is the question, why should I use IAM Roles Anywhere? And what is the benefit of using IAM Roles Anywhere? With IAM Roles Anywhere, you don't need anymore to manage and distribute long-lived credentials on your own for the workloads running outside of AWS. However, using IAM Roles Anywhere, you can get the immediate security benefit of obtaining temporary credentials for your workload to perform and access AWS resources without needing to manage the long-lived credential, which can help improving your security posture. Also, using IAM Roles Anywhere, you can leverage the same IAM roles and policies that are existing today for your AWS application and extend it to your application running on the cloud in order to use and enforce the same policies that are assigned to the role. It is available today in most of our commercial regions at no additional cost, and it also can help reducing the operational cost and complexity by not depending on the third-party tools or the open source that you need for these kind of use cases. And when you're ready to migrate your data and your workloads to the cloud, you can do that in a quicker way and an easy way with minimum changes, since you don't have any dependency on third-party tools. So the next question is, when should I use the IAM Roles Anywhere? In general, IAM Roles Anywhere can be used in any workloads that's running outside of AWS, and you need this workload to access AWS resources. However, we picked you some of the use case based on what we got from our customers, as well as the pattern that we have seen. So one of the use cases, you can use IAM Roles Anywhere to back up your on-premises data to Amazon S3 bucket. This is one of the use case. Another use case you can use to give access to your workloads running outside of AWS to access the AWS Secret Manager. Also, you can use it to send the security findings in your on-premises to AWS Security Hub, or you can use it in a hybrid scenario, as I was referring in a multi-year migration project, where you need to have some of your application running on premises and the others running on AWS, and you want to have a consistent integration between both of the application to access AWS resources. Last but not least, you can also use IAM Roles Anywhere for your application in case you would like to leverage AWS for burst capacity. Here is now Raj, the software development manager. He will be covering today how IAM works, how IAM roles works, and he will be also covering the authentication and the configuration API, and he will give us also introduction about the Credential Helper. Raj, the floor is yours. Thank you.
Thank you, Kish. Hi, I'm Raj. I'm going to talk about how you can work with IAM Roles Anywhere. What do you do to configure it, and how does the entire process of configuration works. All of the steps that I'm going to show, we will be demoing. My colleague Bob will be demoing all of these steps after me, so you can see this working. So the first step, as it says, is establish trust. So the whole concept of IAM Roles Anywhere is you're getting external identities that are not in AWS into AWS, so AWS can trust and vend temporary AWS credentials that can be further used for accessing other AWS services. So to establish this trust, you'll have to import your CA cert and create a resource called Trust Anchor. The CA cert will be validated when you import it. If it is in fact the CA cert, does it have the required strength? Is it not a public CA? If you do not have a PKI system of your own that you manage, you can always use Amazon's ACM PCA. You can spin up a PKI infrastructure via PCA and then refer that to here, so you can create the Trust Anchor resource. Once the trust is established, you now have to configure the role trust policy. So what this is the roles that you want IAM Roles Anywhere to assume on your behalf needs to now trust IAM Roles Anywhere service principal. So the service can assume the role. In addition to that, you also have to give permissions for assume role, obviously to assume the role, set source identity and tag session. Set source identity and tag session is further used for ABAC when you use the credentials elsewhere when you're accessing other AWS resources. The source identity can be traced all the way up to the Cloud3 event. So the source identity comes from the CN of the subject. If you don't have the CN, it will fall back to the serial number of the subject. And the tag session, you can currently we support parsing the subject OIDs that are set as principal tags in the session that can further be used as conditions in your resource policies when you're trying to access other resources via the credentials vended by IAM Roles Anywhere. Once you have the roles trusted, now you'll have to create another IAM Roles Anywhere resource called a profile. Profile has two things. One, the list of roles that IAM roles can assume, and optional session policy, which can be a managed policy or inline policy that can be used to further scope down the vended credentials beyond what's already in the role policy. So if you really want to limit the usage of the credentials to a network boundary, you can just put that condition in the profiles session policy that will be applied when the role is assumed and the end credentials are vended. Once you have these two resources, you now can request for a temporary AWS credentials using our authentication API. That API requires the client cert that is issued by a CA that is previously trusted as part of the Trust Anchor. It needs the Trust Anchor ARN that was just created, the profile ARN, and the role ARN that you're willing to now have IAM roles assume. Once you have these passed, IAM Roles Anywhere will vend temporary credentials that can be used for other accessing other AWS services. We also support an aggregated audit of all the credential transactions that is happening. So this is in addition to what you get in CloudTrail. You already have a CloudTrail event of the authentication action, but in the audit of the activities, what we call a subject activity, has a list of subjects that were presented by for IAM Roles Anywhere to validate and give authenticate, and the list of serial numbers of the certificates that are all using that subject and were presented for authentication. On top of that, you will also have the status of the authentication action, whether it was a successful action, was it a failure action. So this gives you an idea of like a three-step process: establish trust, configure roles, existing roles to trust the service. You can also create new roles with the trust policy that will trust the service. And then you have now credentials, as well as you can authenticate the sessions, and as well as audit and track the sessions. So I'm just going to briefly talk about the trust model, like what exactly happens here. So as I said previously, the PKI is the source of identity that is coming from external your customer networks. The identity is encoded in the subjects of the end entity certificates. The subjects is what IAM Roles Anywhere parses and validates to make sure the certificate is the certificate that is being claimed for. And then the conditions around the subject are used for restricting access based on what was in the trust policy. Once you have the trust established between your PKI and IAM Roles Anywhere, you can now use the end entity certificates to vend the credentials. So what the trust model basically is doing is bridging the role, the IAM roles that you already use, the PKI infrastructure that you previously trusted as part of Trust Anchor, the identities encoded in the end entity certificates that will be presented for authentication when the authentication action happens as part of the authentication API. Once you have the configuration done, once you have the end entity certificate available on the non-AWS workloads, you can now make an assume role call, basically using IAM Roles Anywhere create session API that uses the leave certificate, assumes the role, validates the trust chain, validates if the trust policy is correct. And once all of that is done, it'll go and get the temporary AWS credentials from AWS STS. Those credentials are vended back, which the workloads can now use to authenticate other AWS services. These are the high level on what the configuration and authentication APIs look like. The configuration persona, the config persona does the create trust anchor, create profile. They can also do a update, delete of the profile and the trust anchor. Once that is done by the config persona, there is a provisioning persona that is an existing persona in the customer environment who already either has management tools to deploy the end entity certificates in these non-AWS workloads, or use standard tools to be able to do that. So this step is outside of AWS, where the customers will now have to make sure they can deploy these end entity certificates onto the non-AWS workloads. Once that step is done, the developer persona or the application running on the workloads can request for temporary AWS credentials. So we have IAM Roles Anywhere has published a Credential Helper. This is a tool that does the heavy lifting of certificate parsing, using the new signing specification and generating the signature. It also handles the request to the IAM Roles Anywhere and passes the vendor credentials back in a JSON format so the SDKs can consume. This is built on top of the SDK's credential process that already is available in all language SDKs. We also have published the documentation for the API as well as the new signing specification in case you want to build your own credential process that will parse the certificate and does the signing for you. On top of it, we do have a few distrust mechanisms. The first one is you can disable a trust anchor should you see any anomalies in your usage. You can also disable a profile and you can enable them as you need. On top of it, we do support certificate revocation list that works based off of an import API where you have to import your CRLs to IAM Roles Anywhere. We currently do not support CRL distribution points, callback to CRL distribution points or OCSP endpoints at this point. I'll now hand over to Bob, who will be walking through the usage of IAM Roles Anywhere.
Hey, everybody. My name's Bob, and I'm a senior software development engineer with AWS working on Roles Anywhere. I'm going to reinforce a lot of what was just said in describing how Roles Anywhere works, but I'm going to make it concrete by kind of walking you through, and you can see exactly what happens in the console and some of the capabilities that we've baked in. So, first things first, as we mentioned, the root of trust for Roles Anywhere is now going to be a PKI of some sort, right? So if you're running something on premise like Active Directory certificate services, that'll work. What I've done here is I've gone ahead and set up an AWS certificate authority, ACM PCA. And basically, this is it's a managed service. You go through the process. We manage the provisioning of the root certificate. And then there are APIs to issue certificates for CSRs, right? So this is very simple. It's an RSA key for it. And then there's the part of actually issuing the certificates themselves. So I've done a bunch of this ahead of time, so I won't go through the details. But if you've done any PKI work, you've probably used commands like this, similar. So we open up we generate a key, right? So a private key, and then a certificate request. And I want to draw your attention to the subject. One of the things that Roles Anywhere will do is it will parse the subject into all of the RDNs and then turn those into tags you could use for attribute-based access control. So in this case, it's a pretty simple subject. I have a common name and then a unique identifier, and it outputs it to a CSR. So with that certificate signing request in hand, I can then use the PCA API to issue a certificate. Again, so I elided it because it's really long. I have the PCA ARN, and then I pass the CSR I just created. I'm going to do 365 days. We've heard from a lot of customers, they want shorter periods. They're going to issue a lot of certs and do very ephemeral certificates. And I'm just going to specify a signing algorithm that's compatible with the key I allocated for the server. So I get that. It comes back in a JSON format. So you get a response that tells you here's the URL or the ARN to get the certificate, and here's the ARN of the certificate authority. And so you call a method to get that certificate, and it comes back as a PEM encoded certificate, and I store it off to disk. So if I take a look at what we've done, I'm going to copy the command here, come over to a shell. Oops, I copied the wrong command. Hold on. We're going to look at the certificate itself. So some details for the certificate. We enforce certain constraints. So we'll reject certificates that have weak hashes or keys that are too small for our standards. But you can see the subject. This is one of the subjects that has multiple RDNs in it. And we're going to use that to authenticate, or actually to authorize this certificate, the identity asserted in this certificate, to access Roles Anywhere. So now that I've got the PKI, I've got the certificate authority, I've got certificates provisioned, I now can go into Roles Anywhere and create a trust anchor. So a trust anchor, like I mentioned, it can be a certificate that you've gotten from your CA. You can just upload the PEM file, or in this particular case, I just linked it to the PCA that I had previously created. So we automatically pull that certificate in, and we can do trust validation on the certificate that's being used to authenticate. Second part of the process is to create what we call a profile. And a profile basically allows you to specify sets of roles that you're going to use to authenticate. And there's a trust relationship with the role as well. But what we're saying is you can use this role And you can also apply additional constraints to the authentication. So if you're familiar with the STS APIs like assume role with SAML, you can specify additional policies or constraints. And you can pre-configure those in these profiles. For example, some customers said that what they want to do is they want to make sure that they can constrain use of the credentials that are issued to their data center. So if they know the egress IP from their data center, they can attach a session policy to all of the credentials that are issued and use the source IP address. So I didn't specify any for this, but if I'd done an inline policy or reference to managed policy, when I assume this role through Roles Anywhere, those additional constraints would be part of that session. And I want to point out as well, I'm going to go into the IAM console here. We'll see. And we're going to find the role in question. And we're going to look at the trust relationship for it. So I'm going to highlight a few different things. One, it should look really familiar if you've set up roles to be assumed by AWS services. So you have to trust the Roles Anywhere service principle. In addition to assume role, we actually also set source identity, which is a STS feature to attach your external ID to the session for traceability. And then we're also tagging the session. So the individual RDNs that come out of the certificate become principal tags in the session that you can use for that attribute-based access control. And so for this particular case, I'm also using that same attribute to control access to the role. So I've allowed the two principals in this case, the Bob and the Alice certificates, their CNs, they'll be able to access this role. So just really simply, if we take a look at what I'm going to invoke, I'm going to invoke one of these commands here. And what I'm going to highlight next is to make all of this work, we actually have a small credential helper that works with the SDK. And if you've worked with the SDK, you know that there's an extension point called credential process that allows the SDK to shell out to a program that can generate or retrieve credentials in any way it sees fit. So what we have is this signing helper that takes a command that looks a little bit like this. I included all of the information, but the basics are, there's the endpoint for the regional endpoint for the service. I'm telling it it's going to be in US East 2. I've got a path to the certificate that I'm going to authenticate with, a path to the private key, the ARN of the trust anchor that I showed you earlier, the ARN of the profile, and the ARN of the role that we're actually going to try and assume. So that profile can actually contain multiple roles. So I specify which one I'm going to assume. And then credential process is a flag to this tool to tell it to output the result in the format that is recognizable to the SDK. So all of these tools use this format, and it's all the same information you would put in environment variables or put into the config file. This is just the format that the SDK expects when it invokes the credential process. So the access key, the secret access key, and then the session token. So you invoke that, the SDK invokes that command through a profile. And I'll show that really quickly. So the profile will look something like this. I'll specify one profile for Bob and one profile for Alice. It'll invoke that command, and it is a bit verbose because the ARNs are pretty large, but the information's pretty straightforward. So if you come back to the command line, I'm going to issue a command that uses one of those profiles. We're going to say, we're going to take Bob and we're going to list the certificate authorities. So when this runs, the SDK is going to invoke the credential process, get that JSON back, and then output. This is the result of that API, right? And another thing I'm going to highlight is when you look at the attribute-based access control. Now, one of the things I highlighted in here was we took the common name and used that to authorize access to this particular role. But I have in a separate account setup an S3 bucket, and I can take that session, and just like with any session, I can use a resource policy or a bucket policy to grant access. And in this case, I'm going to tie it to a different attribute from the certificate. So if I come back and sort of get one of my commands here, I'm going to take Bob, and I have this same exact text file stored in that location. Make sure I got that right. And so the way this command works is it gets the object, you specify which bucket, and then that temp.md will have the contents of the file I just downloaded, right? But if I replace it and I use that other profile for Alice, whose UID does not match this condition, as expected, to get an access denied, right? So you can use attributes in the certificate to refine both access to the role itself and then to the resources you want to be able to access. And finally, I want to point out within CloudTrail, this information becomes available to you so that you can have some traceability to which credential was used for which action. Let me increase the size of this. So the things I'm going to point out here, I'd mentioned that we take that source identity from the certificate. So in this case, we take the common name and we map it to the source identity. But we also, if you've ever looked at your session issuer or user identity field in CloudTrail, you get a session name when you assume a role, whether it's through SAML, web identity, or just assume role. You have to pass in a role session name. And we take the hex encoded serial number so that you can then tie that back to which certificate was actually used to authenticate. And then finally, I want to highlight that we do distrust at multiple levels. So one feature is you can import CRLs to a trust anchor so that we check the revocation. But you can also just very simply disable either the profile or the trust anchor itself. So if I take this trust anchor and I'm going to disable it, and then I come back to execute one of those earlier commands, it's going to fail because I've essentially turned off the trust mechanism to the certificate authority. So hopefully that lets you connect all the different pieces, right? PKI has a lot of moving parts to it, but what we have is we have the certificate authority, the certificate that from that authority that's used as a trust anchor, which we use to then validate the authenticating certificate, and then a profile that lets you refine what roles and what additional constraints or policies are going to get attached to that particular role session once it's been assumed. And then the traceability that you get by being able to do both attribute-based access control, taking information from the certificate about the identity and use that to refine authorization, and then be able to identify which credential was used for which actions inside of the system. So with that, I'll turn it back over to Kesh.
Thank you, Bob. That was a great demo. Thank you. So we are looking ahead, and we are working on extending the capabilities of IAM Roles Anywhere based on the feedback that we received from our customers. So in the couple of weeks, the couple of upcoming weeks, we'll be open sourcing the Credential Helper, where it will be onboarded on GitHub, and you will have a visibility on the code as well as the authentication method that are being used by IAM Roles Anywhere, and the API used underneath to obtain the temporary credential. We are also working on other Credential Helper enhancement by integrating with OS local certificate store. And also we are working on the support of custom configurable mapping for certificate fields that you can use to add additional condition statements based and reduce the authentication of your workloads by extracting parameter from the X509 certificate, which help to further restrict the authentication of the workloads. Also, we are working on supporting AWS organizations, which will give you a central view to manage your IAM Roles Anywhere resources, and where you can share them across different accounts. And last but not least, as I mentioned, that the IAM Roles Anywhere was launched in most of our commercial region, but also we are extending that feature to additional commercial region. Now, how many of you feel that they need to dig further and learn more about IAM Roles Anywhere? Please raise your hands. Awesome. So here is some additional resources that we believe could be helpful for you. So the first one is a reference to our user guide, where you get a full documentation about IAM Roles Anywhere and how it works, and all the configuration that my colleagues showed to you today. We are also having here the reference of the API, and where you will see all the APIs that you can use to configure IAM Roles Anywhere. This is a link for the console. So as Bob was showing, that from the IAM Roles landing page, you can go and manage and start managing the IAM Roles Anywhere feature from there. And last but not least, also, this is a reference to a technical blog where it gives a step-by-step procedure needed to set up the IAM Roles Anywhere and start obtaining the temporary credential for your workloads. I would encourage every one of you to now take whenever you learned here with your team and spend time reading and testing IAM Roles Anywhere. In today's session, we covered an introduction about IAM Roles Anywhere and how you can use it to extend the IAM roles and policies to your workloads running outside of AWS in order to obtain temporary credential to access AWS resources. Some of you might have questions, or you need any help. Here are our contacts, and feel free to take picture. Also, we'll be standing here outside just to address or answer any of your questions. And we would love also to meet you and gather your feedback about any other capabilities that you may need or may your use case may need. Now, one last thing. I know that this is the most important thing. I know that you attended since yesterday a lot of session and you provided the feedback. This is really very important to us. I would encourage every one of you to go and fill out the survey from the mobile app. And put your feedback regarding this session. Thank you so much for coming here today, and it was a pleasure meeting you. Thank you.